Okay? So if we're gonna change our price 3 times, and each change is worth 5 cents, then that means I modify my price by 15 cents. Okay, we're only gonna do one more problem, mainly because I didn't run off enough problems, so we're gonna just do number 62. Now, to do number 62, we need to know the projectile motion formula, which they are assuming you know because we had it before, but I'll give it to you if you need it. I'll give you the formula just like I gave it to you before. This is the projectile motion. So in this case, we are have initial velocity of 48 and an initial height of 3.5. So here is our formula. Okay, do you vaguely remember that from before? Initial velocity, initial height, I just plug the numbers in from the problem. Now, find an equation right there. So that's A. That's your equation. What is the maximum height, and when will it reach that maximum height? Okay, you don't need a calculator because what kind of equation is this? Parabola. And if we want a maximum and it's a parabola, we just find the vertex, right? So, negative b over 2a, I think that's 1.5. Yeah, 1.5, 3 halves. So what is that? 1.5 what?
At the seconds.
Seconds. That's the time. So the question said, when does one of the questions was, when does the ball reach its maximum height? 1.5 seconds. Now the other question is, what is the maximum height? Well, how are we going to figure that out? Plug it in. So negative 16 times 1.5 squared plus 48 times 1.5 plus 3.5. Just plug it in. Uh, 39.5 is what I got. Anybody else get that? And that would be feet. So what is the maximum height? 39.5 feet. When does it get there? After 1.5 seconds. All right, 2.1 done. Easy, a lot of review. So 2.2 is probably the shortest section, one of the shortest sections in the book. We may not do all of these exercises. Keep your papers out because we're going to be going back to those. But here we go. We're going to talk a little bit about variation, direct and inverse variation. So I want you to think about this for a second. I love bananas. When I go to the store, if I get a big bundle of bananas and I go check out, I pay a certain amount of money. What if I get a smaller bundle of bananas? Then I pay less money, right? So fewer bananas, fewer coins, right? Fewer money. More bananas, more money. That is called direct variation. When you have two quantities, in this case, pounds of bananas and money, and they go in the same direction. More bananas means more money. That is called direct variation. And the formula for direct variation is simply y equals kx. Now, typically, we use the letter k, but you might be more familiar with it as an m. Y equals mx is what? The equation of a line through the origin. That is a direct variation line right there. So if I buy 1 pound of bananas, it costs me this much. 2 pounds cost me this much, and so on and so on and so on. That is a direct variation. K is simply the constant of variation. In my example, it would be the cost per pound of bananas. If bananas are 50 cents a pound, then what I pay is 50 cents times the number of pounds I buy. Direct variation. All right, now think of this situation. Suppose I'm at my house and I drive to school at 30 miles an hour. Okay? Takes me a certain amount of time to get here. Now, suppose I'm at my house, I drive the same route at 40 miles an hour. What happens? It takes me less time. So more speed is less time. That's inverse variation. When the two things you're comparing in your problem are moving in opposite directions, as one goes up, the other one comes down, that's called inverse variation. And the formula for inverse variation is y equals k over x. That is not linear. That is a reciprocal function. So it looks way different when you graph it. But direct variation, y equals k times x. Inverse variation, sometimes called indirect variation, is k over x. Okay? Now, a power function is anything of the form y equals something times x to a power. So a power function is something times x to a power. And the power can be anything except 0. So the n here can be a positive number, it can be a fraction, it can be a negative number, it can be anything except 0. Because what happens if that happened to be 0? What's something to the 0 power? 1. So this would just be y equals k. It wouldn't be an x anymore. So this can be anything you want it to be, but it can't be 0. Okay? Now, the interesting thing is, and let's look at our note or our textbook now. Oh wait, first we got one more question. Which BFFs are power functions? So I know this is hard. Think of your 12 BFFs. Okay, is that a power function? Yep, because what's the exponent? 1's not 0, right? That's a power function. What about this one?
Yeah.
Yep, that's a power function. What about this one?
Yeah.
Yep. What about this one? No exponent, right? That's not a polynomial. There's no exponent. So that one's not. I'm trying to think. Sine and cosine are not, right? How about this one? This is a tricky one. You got to think back to last year. That is because the square root of x is x to the 1/2 power. A radical is a fractional exponent. So that one is a power function. And actually, so is this, because 1 over x is x to the -1st. Shoot, I'm trying to think of my other BFFs. The logistic function is not. The logarithm function is not. So logistic, logarithm, exponential, those are not. How many do I have? 1, 2, 3, 4, 5. Oh, greatest integer. It is not. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got them all. So which ones are power functions? The ones I don't have marked out. Okay? You don't need to memorize that. Just know what it means to be a power function. It means you have an exponent and nothing else. It's just something of the form y equals k x to the nth.
Why is it exponential?
Because the exponent is actually an x, not a number.
Oh.
right? It's e to the x, yeah. So it's backwards of the power function. All right, now let's look on page 197. And we're starting with problems 37 to 42. Do not be confused. I want you to notice something that you already know. I am going to draw this function right here, but just the part in the first quadrant. Would you agree that that's what it looks like when you have x to the first? It's in the first quadrant. It's just that because it's a line. Now, I'm going to draw these two together. In the first quadrant, would you agree that these two have a shape sort of like that? So I want you to look at the pictures they drew in quadrant 1 for 37 to 42. In quadrant 1, would you agree that C, picture C looks like this one, and picture B looks like this one? Okay, now, the square root function only exists in quadrant 1, and it looks like that. So in terms of your pictures, that would be D. And then the reciprocal function looks like this, and that would be A. Are you with me? Now, I want you to listen. This is going to be big. It'll be important here. If your exponent is 1, then that's what you got, period. If your exponent is any other positive number bigger than 1, so a number bigger than 1, like 2 or 3, it's going to look like this. In quadrant 1, it's going to have that shape. If it's a fraction, so between 0 and 1, like 1/2, 1/3, 1/5, 2/5, it's going to have this shape. And if it's a negative exponent of any size, it's going to have this shape. All right, so if you still remember your BFF shapes, then you know exactly what power functions are going to look like. If you put a negative coefficient on the front of anything, what does it do? What does a negative on the front do?
Upside down.
Upside down. So instead of having that picture, you would have this picture. So the ones they drew in quadrant 4 are just the upside downs of the ones they drew in quadrant 1. Got it? Okay, so now we're going to look at number 37. 37 has an exponent bigger than 1, so it has this shape. But it's got a negative, so it's actually going to have this shape. So 37 is graph G. Are you understanding what I'm doing here? Okay, let's do one more together, and then I'm going to have you fill in the rest. Okay, number 38. 38 has a negative exponent. Negative exponents of any size look like this right here. It doesn't have a negative coefficient, so that is graph A. So 38 is graph A. All right, see if you can do the rest of them in that little section, 39 to 42. See if you can figure them out, 39 to 42. Remember, this is the shape if it's bigger than 1. This is the shape if it's between 0 and 1. And this is the shape if it's negative. guess for 39? Or maybe not, guess is the wrong word. Who knows what 39 is?
Is it D?
It is D. Why is 39 D? Because the exponent is between 0 and 1. Okay? How about 40? Who's got an idea for 40? Allie? Which one?
E.
E.
Is that wrong?
It is. Because, and I know what you're thinking. You're thinking that this is for the exponent's fractional. But it's a fraction bigger than 1. And any exponent bigger than 1 is going to have this shape, Allie, right here, okay? So since it's got a negative out in front, the answer to 40 is actually G. Okay? So the whole fractional deal, guys, that's between 0 and 1. So it's a fraction less than 1. Anything bigger than 1 is going to look like this. Okay? All right, how about 41? Who's got a plan for 41?
Is it H?
It is H. It is H. Because the exponent is negative, and so is the coefficient. And 42. D. It's a D. Because 2/3 is between 0 and 1. And that's this guy right here. Okay, you all right with that, everybody? All right, let's crank through a few of these now. On 197, it says number 17. Write the statement as a power function. Use K as the constant of variation. So, we need to remember that if it varies directly, this is our format. And if it varies inversely, this is our format. So, the area of an equilateral triangle varies directly as the square of its sides. So, this is my format. It says use K for the constant of variation. So, area is K times S squared. Varies directly. The volume of a circular cylinder with fixed height is proportional to the square of its radius. Mrs. Ford, you tricked us. Is proportional means varies directly. It's another word for varies directly. If things are proportional, that means they both get bigger and they both get smaller together. That's what proportional means. So the word proportional, without any other word with it, just proportional, means varies directly. All right. The current I is inversely proportional to the resistance R. So that should be this, except they tell me the constant of variation is V. So they tell me to use V instead of K. These problems are super simple. Please don't get confused. You're either going to set up a product like this, K times something, or K divided by something. And they'll tell you what to set up. All right, Charles' law states the volume of a gas varies directly as the absolute temperature T. Now notice, I don't, there's a bunch of other gunk in the problem, not important stuff. Well, not for this, it's not important. So we're just not we're ignoring it, just not taking it into account. All right, the energy E is proportional to the mass M. Oh wait, is proportional to the mass M with the constant of variation being c squared. You've seen that before, E equals mc squared. Last one. The speed of a free-falling object varies as the square root. Okay, now wait, it just says varies. Do you think that means directly or inversely? If it doesn't have a word attached to it, what do you think it is? It's direct. It's direct. If they don't use that word, that's what it is. So it varies directly as the square root of D, and the constant is the square root of 2G. So the speed varies directly. Oh, it says speed P. I'm supposed to be using P, sorry. The speed P varies directly as the square root of the distance, and K is the square root of 2G. Can I put those together and write 2GD? Can I put those together? Yeah. If they're both square roots, you can put them together. All right, number, thank you. All right, page 196, quickly, we're gonna do just these ones at the top and then we'll be done. Here we go. Determine whether the function is a power function. For those that all state the power and constant of variation. Okay, is one, I'm on page 290, or page 196, up at the top, section 2.2 of my textbook. Is one a power function? Yes. The variation, the constant of variation is -1/2, and the power is 5. Easy. Is number 2 a power function? Yes. The constant of variation is 9, and the power is 5/3. Number 3. No. Because to be a power function, your power has to be a number. 3, Allie, is exponential. 3 is what we call an exponential function because x is the exponent. So 3 is not a power function. Number 4, kind of tricky. It is not really a power function because what would its exponent be? No. Its exponent would have to be 0 because there is no x visible, right? That's a horizontal line. That is not a power function. All right, how about E? C is a constant. So that is a power function, but C is the constant, so the power is actually 1. M is your variable. All right, I'm going to stop rushing now. I want everybody to look at number 5 and go back to the directions. C is a constant, so that means C is a regular number, like 5. What then is my variable? If C is a constant, then my variable has to be M, and the power on M is 1. So it's a power function. M is your variable, 1 is your power, and your constant of variation is C squared. All right, that's enough. We'll stop there. I crammed a lot in. We will pick up there. Okay, so let's work on our 2-1 homework.